Hi everyone, my name is Joyce and this is my CSE 335 class project, Profit Exchange. So Profit Exchange is a mobile marketplace application for buying and selling professional clothing. The main idea is to help students and young professionals find affordable professional outfits for interviews, presentations, internships, career fairs, and workplace events. So in this presentation, I will explain the project idea, the main use cases, the MVVM architecture, the application walkthrough, the technical implementation details, and finally the capabilities, limitations, lessons learned, and suggestions for the class. The problem I wanted to solve is that students and young professionals often need professional clothing quickly, but buying new business clothing can be expensive. It can also be wasteful if the clothing is only used for a few interviews or formal events. So my solution is the Profit Exchange, an app where users can post, browse, filter, favorite, message, and purchase professional clothing listings. The application also supports local pickup, so users can find items near them instead of relying on shipping. From a technical point of view, this project demonstrates several important mobile development concepts. First, the app follows the MVVM architecture, which separates the user interface from the business logic and data models. Second, it uses persistent models so listings, users, messages, and transactions can be stored. Third, it includes API decoding, where web API products are fetched and mapped into local listings. And finally, the app includes map-based functionality for pick-up location support. And this slide shows the use case diagram for the application. There are two main actors, the buyer and the seller. Some use cases are shared by both users, such as register or login, send messages, and manage profile. These are common actions that both buyers and sellers need. And for the buyer side, the main use cases include browsing items, searching and filtering items, viewing item details, adding items into favorites, sending messages, and purchasing items. So this supports the complete buyer flow from discovering an item to confirming a purchase. And from the seller side, the main use cases include posting an item, editing a listing, deleting a listing, managing profile, and communicating with buyers. So this allows sellers to create and maintain their clothing listings. Overall, the use case diagram helped me define the main features before implementation and make sure the app supports both buyer and seller workflows. This slide shows the MVVM architecture diagram for my implementation. The left side is the view layer. It includes views such as content view, login view, main tab view, home view, favorites view, profile view, item detail view, post item view, message view, pickup location view, and transaction history view. So these views are responsible for displaying the user interface and receiving user interactions. The middle section is the view model layer. My main view models are user view model, item view model, message view model, and transaction view model. So these classes conform to observable object and use published variables to update the UI when data changes. For example, user view model manages login and register state. Item view model manages searching, filtering, listing creation, favorites, API loading, and distance calculations. Message view model handles sending and deleting messages, and transaction view model handles purchase actions. The right side is the model layer. The main models are listing, app user, chat message, transaction record, and API product. Most of these are Swift data models, and API product is a codable struct used for decoding JSON from the web API. The diagram also shows Swift data support, including model context and queries. The views can read stored data using query, and the view models can insert, delete, update, and save model objects through model content. The main reason I use MVVM is that it keeps the views cleaner. Instead of putting all filtering, login, API, and purchase logic directly inside the UI, that logic is moved into the view models. And next, the slide shows major screens of the application. So the first screen is the login and register screen. Users can either log in with existing information or create a new account. After login or registration, the user is taken into the main app. And the second screen is the Browse Item screen. Here, users can see available professional clothing listings. Each listing shows basic information such as title, brand, size, price, and pickup location information. Users can also search and filter listing based on their needs. The third screen is the item detail screen. When a user selects a listing, they can see more detailed information including category, brand, size, condition, seller, pickup location, and description. From here, users can favorite the item, view the pickup map, purchase the item, or message the seller. The fourth screen is the messages screen. This allows buyers and sellers to communicate inside the app. Users can view message history and send new messages about an item. The fifth screen is the pickup map. This supports the local pickup feature by showing the pickup location on the map. The app can also use location-related data to support distance filtering and sorting. The last screen is the post item screen. This is mainly for sellers, and sellers can enter listing information such as title, category, brand, size, price, condition, pickup address, image, and description. So after posting, the listing becomes available in the marketplace. Together, these screens demonstrate the main application flow. Log in, browse, view items, communicate, use map support, and post items. So this slide explains the main technical implementation details. First, the app uses Swift data persistence. The model classes store listing, users' messages, and transaction records. Query is used to read models and data into Swift UI views, and model context is used to insert, delete, update, and save changes. This allows the app data to persist instead of disappearing every time the app refreshes. Second, the app includes Web API JSON support. So API services use async URL session to fetch product data from a web API. Then JSON decoder decodes the response to API product objects. These API products are mapped into listing objects and saved locally so they can appear together with local marketplace listings. And third, the app includes location and map support. So Pickup Location Manager publishes the user location, and pickup addresses can be converted into coordinates. The app also stores distance value by listing ID, which supports distance filtering and sorting. This is important because local pickup is one of the main features of the app. Overall, these technical features show that the app is not only a UI prototype, it includes persistent data, external API processing, and location-based functionality. And this final slide summarizes the project. For capabilities, the app supports register and login, profile flow, browsing, searching, filtering, favoriting items, posting listings, viewing item details, messaging users, recording purchases, Swift data persistence, API support, and map support. For limitations, the app does not have a real payment provider yet. The messaging feature is also local and not a real-time server chat system. Also, image handling currently uses URL style data instead of a full cloud image upload system. For the lessons learned, I learned that MVVM makes the project easier to organize because the view models can manage logic separately from the views. I also learned that state and persistence need clear ownership. For example, deciding what belongs in the view, what belongs in the view model, and what should be stored in Swift data is very important. I also learned that map features require asynchronous handling and fallback logic because location and geocoding do not always return immediately. And finally, for class suggestions, I think it would be helpful to provide more starter examples for Swift data, API decoding, and MapKit. I also think it will help students if grades and feedback after each phase were returned faster before the next submission. And finally, more sample diagrams before the due date would make the architecture and documentation expectations clearer. And this concludes my technical presentation for Profit Exchange. Thank you for watching.